Hi, this is Trey Wu, and I'm going to introduce bulls and cows. And this is a game like if there's a player 1 and with 7891, and the player 2 is going to guess this number. So if the player 2 guess 30327, which means there's 7 is the correct number but with the wrong position. So the player 1 will give player 2 1B, which means the wrong position but the correct number. And player 1 will guess 2, 3, 4, 5. And if player 1 given 2, 1, 7, 8, which means the 2 is correct number with correct position, so it will get 1A. So and there will be 2 GPU competitive with each other, and until who get 4A first. So let's dive into the code. Okay. So and yeah, not everyone can get this 2 GPU in one device. So in this section, I will use 1 GPU because I only get 1 GPU. And we will create 2 objects, GPU1 and GPU2. And and they'll generate their GPU. They will have their name and secret code. And let's start it. And the first run will go like GPU1 will go first, and the GPU1 gets and the GPU2 will evaluate. And the next turn is GPU2 guess and GPU1 evaluate. So let's start to how they guess. I think is the most important part. Okay, let's see. In the beginning, when the object is created, they will generate all of the code, like from 0, 1, 2, 3 to 7, 6, 7, 8, 9. Like entire all of the permutation will be generated and set into the possible code. And each player will try to reduce the possible code by their history. Like okay, so let's start this. So okay, we will return the possible code if the history is empty. And let's allocate memory. And okay, this is a tricky part. Like we will get something like if the result is like 2A1B, something like that, and it will be the result will be 2A1B, and we will get the first number like 2 and minus 0, which means 2, and the result is 1, so mine is 1. So I will calculate into a number so that it's more easy to store. That will be like 2A1B will be 21. Yeah, exactly. So let's continue. Okay, and okay, we will allocate the memory on a host and copy the data to GPU memory, the global memory, and run the cuda to calculate, and copy back to our host and check which is valid, and put the valid back to possible code. So our next run will get less possible code and free the memory. And this is the some kind of corner case, like possible code is empty, and if that so, and we will start regenerate a random code again and start to calculate over again. Yeah. Okay, let's do this. Okay, let's start to the launch filter candidate, and this will be all the possible code, the length, and the history, and the feedback. And history and feedback will be the same index, like the first to first, yeah, something like that. Okay, let's get into it. And we have 256 block and the grid size again. Okay, and each all of the possible code will be one thread in CUDA in GPU, and we'll follow for all of the history. If the code is 1 2 3 4, and we'll check the history. Like if the history is 3 to 3 no 1 till 1 till 6 7, and it will be 2 no will be 3 okay will be 2A 1B, yeah, and we will check like it in that edge index if the feedback is correct, and this possible code will be valid, and yeah, and all of the CUDA kernel will do everything same, yeah, and we will set the value to false if it is not valid, and return back to and back to here, and we will just like I mentioned before, we will push back and filter, and until, and yeah, let's get back, and until the possible code will be 4A, and yeah, it will update in here, like yeah, and next round the GPU1 will check will send the code to, will evaluate the guess, and if the A1 is 4 and the code is N, yeah. Okay, let's check, and I'm using CMake to run it, so we just need to make, just need to run make and it will run everything, like cleaning directory, building the driver, and run the code, and yeah, as a result, let's get started, and using the same GPU because only one GPU, and the secret code, and they will start to guess, and yeah, and the GPU2 win. And that's it, and thank you everyone.